session, for the next 3 sessions, we're going to be talking about testing. First up is Andrew Burrows, who is going to talk about mocking and patching in the real world.
Cool. Excellent. Thank you for coming. My name's Andy Burrows. I work for ManHL, which is a London-based systematic quant investment manager. But it's kind of also more, we like to think of it more as sort of technology business. Everyone there codes. I've got actual photographic evidence of our CEO coding. I've even helped our sales guys write Python. And we put a lot of the stuff that we can, the stuff that isn't IP sensitive, on our GitHub. So do feel free to check out ManHL Tech. And my CTO would love it if you followed him on Twitter, or us on Twitter, at ManHL Tech. But over the years, I've been involved in teaching quite a lot about testing and mocking. And normally what happens, you kind of deliver a course on testing or mocking, and then within a couple of weeks, people start coming back to you with like, oh, I tried to do the stuff, but I've just, how do I test this thing? How do I mock that thing? So what this talk is trying to be is kind of all those kind of real life kind of war stories all kind of bundled up and brought together. Cool. So that's a bit about me and the talk. What about you? Well, I'm assuming that you already write tests. This isn't going to be why you need to write tests. That's a whole nother story. But you do need to write tests. It's not going to be an introduction to mocking unless you're a really fast learner, because I will go through a really quick recap, but it's not going to be a whole intro. I also assume that you like looking at really ugly slides, but I feel really bad because all the slides I've seen so far today have been beautiful, and mine really don't measure up, so I'm sorry. I put some pictures of cats in just to kind of add some balance. Look out for those. Cool. Okay, so let's start with a quick recap. I assume you already do know why you should be testing and what tests do for you. But I thought it's more interesting to just remember what tests don't do and what your tests shouldn't be doing. Our unit tests should only test one thing, and our unit tests should be really quick to run. And in fact, our whole test suite should be quick to run. We want to be able to run this again and again. We shouldn't be accessing production services or possibly even any services at all. We don't want our tests to fail because of sort of spurious environmental reasons. And we don't want our tests to have any kind of weird side effects outside of the test environment. So how do we achieve this? Well, this is a smart crowd, so you're all thinking he's talking about mocks. Mocks are the answer. And that's partly true. I like to think of it kind of a bit bigger than that and think about test doubles. I categorize a test double as any test object you use in place of a real object in your tests. And I consider test doubles on a kind of spectrum. At the top, we've got fakes. These are kind of fully featured things. They have all the logic you could hope for, and they have state. So a classic example for this would be using an in-memory database instead of a real database. At the opposite end of the spectrum, we have dummies. And in Python, we use sentinels for these. They have no logic. They have no state. You can't even interact with them. You just use them to trace data through your system. Then in the middle, we have mocks and stubs. And in Python, we don't really differentiate very much, whereas in other languages you might. But the main difference is how much logic you put into them. Mocks are generally quite, they don't have much logic, they don't pretend to do very much, and they don't have any state, whereas stubs could have. And you can achieve this in Python through a variety of techniques by using the same mock class. But I won't really talk much about that today. The reason I kind of bring this up is, as we go through our examples, I want to kind of go back to this and start thinking about whether or not we're picking the right place in the spectrum for any particular test we're doing. Okay, so as part of our recap, here's an example of some code you might want to test. In fact, this code looks slightly similar to something that came up in one of the sessions this morning. It's a nightly batch job, and it's going to load some stuff, run some stuff, send a report. What do we worry about when we test this? I mean, I worry that it's called nightly job. Maybe it only runs at night. Maybe it's impossible to test it in daylight hours. That would be a pain. But in reality, we're going to worry about find models, because where's it going to find the models? They must be somewhere. They're probably in a service or a database or something. It's going to run these simulations. That sounds like it's going to be slow. Maybe it needs some external compute resource. Maybe it's going to add to my AWS bill. I need to know about that. And indeed, I need to stop it happening. And it's going to send an email. And I know that the support department at example.com don't want an email every time I run my tests. So we need to stop that happening as well. So here's a test for that code. And it's split up into the canonical 3 sections that we do when we're testing with mocks. We've got arrange. We arrange our test environment. So I use patch to inject mocks in for find models and send emails so they can have no weird side effects. And I create a mock engine to pass in. So we have arrange, then we have act. We cause the system of the test to act. So that's just calling it. It's quite a grand title for just the obvious. And then we assert. And asserts are really important to mocks because mocks don't have any state, so all you can assert on is the behavior that they've observed. So here we expect send email to have been called once and only once with these values. Cool. So asserts, I say, are really important, and assert called once with is great, and it's got a whole family of relatives, but sometimes you need a little bit more power, and mock calls is kind of the most powerful of the alternatives. So you can see in this example, right at the bottom, I can assert that mock engine has been called 4 times. It's been called twice on the method schedule simulation and twice on the method wait for results. And it received these parameters, and it happened in this order. So you can assert quite a lot in one statement. And we'll come back to some of this a bit later. Also notice I use the handy call helper. It's like a DSL for expressing calls. It makes the test much easier to read. Okay. Cool, so that's the kind of lightning fast recap done. So if you didn't know about mocks, you now do. So on to the real world examples. The first thing I want to talk about is mocking and patching built-ins. Built-ins are the things you don't need to import to use in your Python. Here's a list of them, there's quite a few. The simplest example of a built-in I could think of was print. We all know print. So here we've got greeter, which will print a message to whoever you like. Testing this from Python 3.5 onwards is actually very straightforward. From 3.5 onwards, patching a built-in function is exactly the same as patching any other function. So here you can see I patch print on example 1, and then the rest of the test kind of flows through from that. But if we were in Python 2, which I'm sure no one is anymore, then print isn't even a function, so we need to get that feature from the future. And if we're in any version of Python earlier than 3.5, then you can't patch a built-in without specifying create equals true. Now, the good news is that the version of mock that is in Python 3.5 is available in the rolling backport mock library. So actually, in any version of Python, you can have the much more concise patch statement. So I would advise you upgrade. Another way to patch built-ins, which you often see when you read about these things on the internet, is patching them on the built-ins module itself, which you can do, and I've done here. But as you can see, one big gotcha with this is that it's different between Python 2 and Python 3. So if you're trying to write code that works in both languages, you can't. But there's another more subtle problem, and that's that we're patching the built-in at the really quite global level at all of Python. So if you look at this example, which uses the built-in isInstance, and we test it just like we did before, and we expect it to work, and what could possibly go wrong? Well, it turns out the thing that goes wrong is that when you call a mock, it calls isInstance, but we've just patched isInstance at the global level to be a mock. So we're going to call it, and it's going to be a mock that calls isInstance that's a mock that calls isInstance that's a mock, and all of a sudden you've got no stack left and you get recursion error. And this is just one example of the sort of weird, subtle bugs you can get if you start patching built-ins at the really global level. So I'd really advise you not to do it. Generally, don't patch anything more globally than you have to, but with built-ins, it can be really weird to work out what's gone wrong. Okay. Our next example is mocking and patching file access. So this is a kind of continuation. of what we've just seen before, because in Python, file access is done via the open built-in. So we've got an example function here that will open a file, loop over the lines in it, and count the number of words in that file. And when we come to test it, what we want to do, I'm using a nice parameterized test in PyTest. Yay for PyTest. I just want to give it example file contents and then assert that it gets the number of words correct. So I want to be able to inject some example file content in without actually making a real file. And the way you do this in the mock library is you patch open like you normally would, but you patch it with mock open, which is a special helper that comes with the mock library for this purpose. And it all works great. But notice that I'm iterating over f.read lines, which is fine. But another thing that's also fine is just to iterate over f. That's also allowed in Python. And someone could refactor between the two. And if they did, this code would stop working. Because it turns out, for some weird oversight, the object you get back from mock open isn't iterable. So you go to Stack Overflow and it gives you this whole kind of concoction you can do to work around this. But this is the moment I kind of take a step back and say, why am I even using a mock here anyway? Is there some other testable that's a better fit? And it's my assertion that there is, and it's string.io. String.io is a kind of an in-memory string-based file that has exactly the same interface as a real file, but isn't a real file. And it's built into Python. So it's guaranteed to have the right interface, and we can use it. It's not some weird library. So instead of using mock open, I patch open to return a string.io object, and I can still give it the file contents, and my test will now work no matter how I iterate over my file. This is even more important with file writing. So in this example, generate file, I'm writing some lines into a file, same as before. I test it, I patch it with mock open, and notice I can assert on all the calls that have happened, so I can check that the right lines were written in. But like the generate file function, it's really quite arbitrary whether I've used write line or write or write lines. And this is just calling out for future me to come through and tidy it up, or one of my colleagues. So can I use the same trick as before to make this test stronger and indeed prettier? And I think I can. So what I can do is I can still use string.io, and I can make open return it. And the nice thing is here, right at the end of the test, I can call getValue on the object, see the full contents of the file, and just assert on that kind of final state of the file. So this means that if I chose to refactor generate file to write it in a character at a time, or a line at a time, or all in one go, the tests still pass. So I've got nice robust tests. The only problem with this is you can't read from a string.io object if it's been closed, so we have to stop the code we're testing from closing it. So we just wrap it in this defeat context manager to do that. It still does get closed. It gets closed by the outer with in the test, so nothing gets leaked, but we just have to be careful about arranging that. Okay, cool. Next, mocking operators. So the simplest example I could think of was a function that checks that something equals 100. But I'm sure you've got more interesting examples. As you probably know, in Python, operator overloading is done by the double underscore methods, the so-called magic methods. So in Python mocking, there's a special class called magic mock, which will allow you to mock those methods. So once you know that, it is just as straightforward as putting a magic mock in and then asserting that equals was called once with 100. But what if we now, for some reason, we're going to be testing that it's been called twice and we want to check the order, check the different values. So here it gets called once with 100 and once with 1,000. So think back to the quick recap. We can do this with mock calls and the lovely call object. So I just assert that the mock calls on the magic mock were equals 100 and equals 1,000. But unfortunately, this won't work because that call object has a double underscore equals method, and we need it because we're doing call equality in this line. Notice the double equals in the middle. So we can't overload that for some weird DSL purpose. So this doesn't mean what you think it means. So we can't use the call DSL here. So we have to fall back to the underlying tuple representation, which is this, which isn't as easy to read, but you only need to do that when you're dealing with magic methods. Okay. Oh, right. Next, patching dictionaries. This is something that comes up quite a bit through a kind of different avenue. If you've got any code that's configured with environment variables, because the environ dictionary is how Python reads its environment variables, patching dictionaries can be a really good way of patching your environment variables. So in this example, we're reading an environment variable to know who to email, and we use patch dict, which is a special type of patch that comes with mock. What patch dict does is, at the beginning of the patch, it squirrels away a copy of the dictionary, and then anything you do to the dictionary during the patch will get thrown away, because at the end of the patch, it puts the copy back in place. When you do the patching, you can optionally choose to clear it, and you can optionally add or overwrite values in it. So in this particular test, I squirt in an alert user and then check that everything works how I expect it to. Another example for this, which is maybe a bit more read-write, not using environ, we've got getUser, which is basically a little cache around what we assume is a very costly load user call. We decide to write some tests, and we're clever, so in the first one we patch load user to return some Sentinel user information. We call it 3 times, and then we assert that it's been called once. So we're so we can prove our caching works. And then in the next test, we know that the cache has been primed by the first test, so we just call it once and show that it never gets called, which seems very clever, and this will work approximately half the time, because the execution order of your test isn't guaranteed, but also it's just a really bad idea to allow any sort of state to leak out from your tests. So how do we fix this? Well, we've patched dict. I can, in the first case, my test really relies on the dictionary not having anything in that would be a cache hit, so I clear the whole dictionary. And in the second one, the test relies on there being that particular value that we can hit, so I patch that in. But in both these cases, the dictionary ends up exactly as it was before the test, so there can be no weird interactions between our tests. Okay. Okay, next, mocking and patching iterators and generators. So, first of all, I've got a staff member generator function. This is a very contrived example. Normally, your generator functions wouldn't just be 4 yields in a row. They'd be doing a whole bunch of calculations or logic and looping and calling out to services and stuff. But for the sake of clarity, this just yields the 4 staff members in our hotel. And then we have a function to calculate the head count, which loops over that and counts how many are in it. Glorified len. And I can test this due to my intimate knowledge of the iterator and iterable interfaces. Coincidentally, in the Madison room right now, there's a guy spending half an hour describing this interface. So you might want to watch that back on the video. Although I'm going to suggest that you don't need to. Well, it's good talk, I'm sure, but you don't need to for this example. Because whilst I can use an intimate knowledge of how iterables and iterators work, and I have done here, I create a magic mock because it all relies on magic methods. I make sure all the right things happen. I get around a bit of a pothole where it turns out that an iterator has to have an iter method that returns itself, but you can't have self-referential mocks. So I have to put a lambda in to break that loop. And I can do all these tricks, and I can produce a test that completely mocks out that generator. But if you look at that test, can you tell me what it's doing exactly? It seems very clever, but it's not very easy to read. Is there something better we can do? So let's go back to thinking about our testables, and is there a testable we can use for a generator that's better than using a mock for it? And I would assert there is, and it's really obvious. Just use a list. Like, lists are iterable, so let's just patch our generator function so that it returns a list of staff members, and then the rest of the test runs. And now we can eyeball this straight away, know what it's doing. Doesn't look magic, scary, or clever. Okay. Cool. Our last example of the day is mocking and patching properties. So I've invented a printer class that is going to be the sort of software wrapper for some sort of real physical printer. I don't know whether this is some sort of 3D printer or some small desktop printer or a whole printing plant. But the either way, it has a online property which is going to tell us whether the printer's online. And it's got a submit job method which, if you call it and the printer's offline, is going to give you an exception. So we might want to test this edge case, but we don't want to hit any of the code that would cause the printer to do something, because we don't have the printer and we shouldn't rely on it. So we write a test where we create a printer object, then we try to patch the online property so that it's false, and then show that we get the exception we expect. Seems very reasonable, but fortunately, properties are a bit kind of subtle in their operation, and you can't patch them on the object. If it was just a constant, just a normal attribute, you could. So instead, the rule is you have to patch properties on the class. But once we do that, the test will run, and it will all work fine. Cool. What if we want to deal with a property that has a getter and a setter? Is that any different? And how can we check that it has been set? So we extend our printer class so that it's got a getter and a setter for online, both of whom are going to talk to the printer, so we really don't call them. And we're going to have a prepare printer method, a function, which is going to give us back a printer that's been set to be online. And we're going to write a test for that. So what we do is we patch the online property, and we've seen the previous slide, so we know to do that on the class. And this time we don't give it a value, we want to put a mock in its place. And then we call prepare printer, and then we check that the mock was called to set the property to be true. And unfortunately, that doesn't work. And again, the reason comes down to kind of some of the intricacies of how properties work, which is probably a whole talk in itself as well. But the kind of short answer is that mock has already thought of this and provides a property mock class you can use. So by mocking the property with property mock, you can now assert that it's been called, and you can write all the tests you like. Okay, cool. So that's kind of the end of our kind of romp through some real-world examples using mock and patch. I hope you can see that the mock library is very flexible. I like to think of it as a kind of a toolbox of different parts, and like you need to know which tool to use for the right job. I think of those, patch is the best. I love patch. I think even if you're not mocking, you can use patch for all sorts of things in your testing. And I think I've shown that sometimes, whilst it might be obvious to use a mock, it's maybe not the easiest to use a mock, and some testables could be a better choice. So it's worth thinking about that when you're looking at a tricky problem. Cool. And also, I did mention earlier, but if you upgrade to the latest version of mock, you'll have a lot less problems. This talk could be twice as long with all the gotchas that are in earlier versions of mock. So the upgrade is definitely worth it if you can do it. Cool. So yeah, that's the end. So if anyone has any questions, I will try to answer them. Yeah?
I saw you were using PyTest. Do you also use PyTest as your test runner? And if so, what settings do you find are sort of practical, and like what extensions are practical to using mocks?
Okay. So the question was, do I use PyTest as my test runner, and what features of that do I use? So the answer is yes. I love PyTest. I think it's really good. And any specific ones for mocks? I don't know. I mean, essentially, I could probably look them up and get back to you, but I have kind of a standard set of recipes, recipe of
Like
options.
and patching.
Okay, so things like that. So I don't tend to use the patching on it. I like to use the patching in the mock library, but really they are kind of equivalent. And but I kind of like the more explicit nature of the one in mock. For parallelism, yes, use that quite a lot. And indeed, one of the things that's nice is if you're actually using mock and patch to keep your tests entirely isolated from each other, then they're much more suitable for being run in parallel. So, yeah. A good test suite should be parallelism without you really thinking about it, I would say. Yep. And
I have a lot of code that needs to read a big block of data out of some data store, and I do a pretty simple application on it. I struggle to figure out a way that I can effectively block the data store when it provides some sort of big block because you have to check the correctness of the aggregate. I usually end up like storing this pickle or something, but it gets really slow when you have a lot of these. Do you have any thoughts about strategies for blocking complicated data?
Okay, so the question was, the gentleman has a lot of code where he loads a big block of data from a data store, runs a very relatively simple piece of code on it, and then he wants to test that. And do I have any strategies for dealing with this scenario? This is actually really similar to the sort of stuff we see at Man AHL, because we are basically doing data science stuff in finance, so we do that a lot. I think my top tip is, I think you're kind of onto the right thing when you talk about having sort of pickles of it or test files of it. It's kind of trying to keep those as condensed as you can. Essentially, you're writing regression tests, and I guess slightly off topic for mocks, but my favorite pattern for a regression test file is, if you're using PyTest, if you run it with PyTest, all the test underscore functions get called, but if you run it just with Python, the main gets called. So what I like to do is write a main that kind of rebases it and generates the files, and my tests in the same file with a test prefix. Because the problem I always find with regression tests is you lose the code that built the files in the first place. Cool. Do we have time for another question, or yeah? Does anyone have another question? Oh, yeah. Oh, sorry. Yes, I pointed to you first. Yeah.
I just was going to ask, so in a lot of places where what you've done is you've given something where you're testing sort of the internal, like, implementation details, and you've refactored it into something that tests the sort of public interface. Do you think that that's something that you always do, or are there going to be sticky situations where you actually have to mock out the implementation details? Just if you're thinking of your tests as a contract, and you're not testing a private interface, or maybe you don't think that's better.
So, long question. I think I see the question was, should you be mocking and patching out the kind of internal details or the public interface?
Yeah, I guess if you don't test, if you're not trying to test the implementation details,
Yeah.
I guess that's the premise. Is that I try not to test the implementation.
I would agree, and I think some of the examples where you kind of saw whole pages that looked like, where the assertion looked like the function you were testing, but kind of turned inside out and are looking a bit weird. I always consider that's kind of a bad code smell for my tests. I think one of the problems with trying to talk about this is you always end up coming up with examples that are maybe not the examples that you'd want to actually have in your real code base, because you've got to make them concise enough to fit on a slide. So I think you're kind of right that you generally want to avoid what I'd kind of call over-mocking your tests. You just want to target the bits that make sense to take out, but generally trying to pitch it at the right level. And what the right level is will vary on the code base. But you can getting an instinct for it, I think, is useful. I say my instinct is usually when the test looks like someone's taken the file and turned it, the function turned it inside out. That's probably a bad test. Whereas if the test looks like documentation of what the function should do, but in code, then that's probably a good test. Does that answer your question? Cool. And nope. Any more questions? I'll be hanging around here. Cool. Thank you very much.